for the video today, we are going to discuss on how to standardize the normal variable x become z, and also how to use them to apply on application questions. Right, so for the previous video, we already learned how to find out the probability from a table. And if you refer to all the examples that we tried in the last video, all the variable that we have is z, like z smaller than 3, z smaller than 1.5, and so on. So z is the standard normal variable. Okay, in exam, they won't give you always z1, they will give you some x. So if let's say they give you x, the normal variable that has different mean and also the variance, then how can we actually change it become z? Okay, so why do we need to change it become z? So from x, we need to change it become z so that we can use the normal table to find out. The normal table is for z, right, which is with the mean 0 and also variance 1. Right, so for this video, we are going to learn how to standardize it. This process we call it as standardize. Okay, to standardize any normal variable x. Okay, so usually in the question, if let's say they tell you that it is normally distributed, right, they will also give you the mean and variance one. So I think I told you before, this is the standard way how we write the symbol. Okay, x is normally distributed. The first value here should be a mean, and then the second value here should be variance. You cannot change the sequence here. The first value must be always the mean. It is standardized one, right? Okay, so how can we standardize? How can we change the x become z? So to change x become z, you need to take the original value x minus the mean divided by standard deviation. So this is the formula. After you carry out this process, your x will become z. Okay, and this is a very important formula. We call it a standardization formula. Yeah, and after that, after you standardize it becomes z in your question, then only you can continue to find out the value for probability from the table. Okay, so maybe we can try to discuss one or two examples here. Okay, if you look at example 4, we are having x unknown z. Okay, but I know that they are normally distributed with mean and also variance. Mean is 125, variance is 400. So if I want to find out the probability for x greater than 135, so you actually cannot find out this value from the table. You need to change it become z first. Okay, how do I change it become z? So 135 minus the mean divided by standard deviation. So standard deviation should be 4 square root 400. Okay, so if you press calculator, the value that you get for z is 0.5. Okay, so z greater than 0.5. How can you find out the value for z greater than 0.5? You need to take 1 minus z smaller than 0.5. So you look for 0.5 on the table. What do you get? So you should get 0.6915. Therefore, after you minus it, the final answer for z greater than 0.5 is 0.3085. Again, if you want it to be safe, then you can change it become 3 significant figure. Alright, so this is how we standardize our x become z. Then only we apply, only we find the probability value from normal distribution table. Okay, so this is the process. That's why you call it standardization. That means you change the x become z. Okay, right. So if you look at all the steps here, it looks like very simple, but there are a few things that you need to know. Okay, first, in the exam, you must show out this step. So some students say, this step is very boring. So a lot of them lazy to find out, they will skip. Straight away write out the 0.5. Okay, so please take note that in the exam, this step will be always given 1 mark, 1 method mark. So if you didn't write out, then it depends on the examiner. If let's say the examiner is very strict, they won't allocate this mark for you. You will get the answer mark only, but no method mark. Alright? Okay, so must write out this step. Okay, so after you write it out, when you press calculator, for this example, we are having a very nice number, which is 0.5. If let's say when you press the calculator and you get a very, very long answer, please make it become 3 decimal places. If let's say when you press the calculator, you get 0.33333333333. So when you want to find out the value from the table, right, keep it to 3 decimal places, which is 0.333. Okay, don't just find out 0.3 or 0.33. Must go up until 3 decimal places. Because from our table, we can find out until 3 decimal places value. Okay, so this is another small thing that you need to know. Yeah, because the value 0.3, 0.33, 0.333 are having different answers. So again, make sure we maximize it until 3 decimal places when you want to find the table. And after that, this one. This one will be given 1 method mark also. Because in exam, right, they will actually have a look. Z greater than something, you cannot find out the answer straight away from the table. You must take 1 minus something like that. Okay? So this one must write it out also because it shows that you know how to use the table correctly. So this is 1 method mark. So don't skip it. Some students say, this one very easy. I straight away take 1 minus the answer. I didn't show this method, this step. So you lost 1 mark also. Yeah, so the final answer, this is what we have. Therefore, in a normal distribution table question, in normal distribution question, the steps are very important. First one, standardization must write it out correctly, which will be given 1 mark. And then this one, although won't give you any mark, but make sure when you want to find a probability, keep it under 3 decimal places. And then the step here is you have to show them how you get a correct final answer. Because from table, you get 0.6915. Right, so this will be given 1 mark, and the correct final answer 1 mark. Okay, so this is what we have for example 1, how to standardize the variable x become z, how to change it become z. Okay, question number 2, 3, 4, I will want you to try out on your own. Okay, so I just leave the final answer here. For example 2, you should get 0.5987. Then this one is 0.7734. This one is 0.2266. Okay, so if let's say you want to try it out, you can also try out this 5 and 6 first. 5 answer is 0. 6 the answer is 0. I think for part 6 we don't need to discuss that because x equals to a number for normal distribution. I told you already, right? No need to try out anything, straight away is equals to 0. Okay, but part 5 is worth for you to try out. So maybe before you continue with my video here, you can complete all the examples first, then only you look at our explanation for part 5. Okay, so part 5, how can you solve it? Why do I get a 0? Okay, so again, this is x, therefore you need to change it to become z. How to change it become z? X minus the mean divided by standard deviation. Same thing happened for the 701 minus the mean divided by standard deviation. Okay, so if you press the calculator correctly, you will get this is 3.75 and this one is 28.75, right? If you press calculator. Okay, so z is between 2 values. Therefore, the next step would be z smaller equals to 28.75 minus z smaller equals to 3.75. So both are smaller than, right? So you can already find out the value from the table. Okay, so if you look at the value from the table, you won't see the 28.75. The largest value that I think you can get is 2.999. Okay, so can you imagine or not, if let's say when you get the value for 2.999, the answer for smaller than 2.999 is very close to 1 already. Okay, so can you imagine or not, if let's say I'm having 28.75, smaller than 28.75, that means it covers the whole area below the graph, okay, on the left hand side of the graph. So the whole area is a 1. Minus z smaller than 3.79, 3.75 maybe here. So smaller than 3.75, it also means that it covers the whole area, so which is 1. So 1 minus 1, you will get a 0. So this is a bit special, just to tell you that if let's say you face all this kind of weird value, so how are you going to look for the value? You have to draw a graph to help you. Okay, so any value after 2.999, there's no more area. So smaller than 3.75 means it actually covers the whole area on the left, which is the whole area is 1. Okay, so this is what we have for the explanation for part number 5. Okay, I hope that you can get the answer. Then the rest of the example you try on your own. Make sure you try it out, write out the proper step, and then try to understand. Okay, so if no problem, then we will proceed to the next part. Okay, so for the next part, example 5 and example 6, they belong to the application question, which is more like example type 1, right? Okay, so before we try out all these application questions, there's a thing that you need to know. For normal distribution question, right? In the question, they will definitely give you the keyword normal distribution. In the question, if you didn't see this word normal distribution, you cannot assume that they are normal. Okay, so it's different from binomial. Binomial, you need to identify the patterns yourself, right? Because there's no keyword. But for normal distribution, 100% they will have keyword one. You must see the word normal distribution. If let's say you totally didn't see any word normal distributed or normal distribution in the question itself, you cannot assume that it is normal. Understand what I say or not? Okay, so once I see that this is normal distributed, then it's very easy. First, I will always write out the correct symbol first. X is normally distributed. Mean is 150. Standard deviation is 10. So I need to have a variance here, which is 10 squared. Okay, so first I always write out the symbol correctly. If let's say you want it to be more detailed, you can write out what is the meaning of X. Okay, the X is the length of strips. If you want to write out in detail. Okay, so first part, find the probability. So probability means P. Okay, that the strip from the production line has a length. So the length of strip is X. Less than means X less than 165. So 165. So we are actually convert a sentence become a symbol. Okay, so probability means P. The length of the strip means X. Less than is less than. 165 means 165. Okay, so we are actually doing some translation work from a sentence to a symbol. Okay, so I think this part you should able to do it already lah. So X you need to change become Z. So the step is 165 minus 150 divided by standard deviation 10. Okay, so please continue in details for this step. Alright, and then I think you should be able to get the answer 0.9332. This is not hard because the steps are very standard. Alright, so I will just leave it for you to make sure that you know how to use the normal table correctly. Okay, and then for part number 2, I will also leave it for you. Okay, so for part number 2, if let's say you want to have a look, they want you to find the probability that the length of strips is between these two numbers. So 127.5 and also 139.2. Okay, so again, standardize it, then follow the steps that you learned before. This answer should be 0.1279. Okay, so this is what we have for part number 2. I will just leave it for you because it's very easy also. And then now I want to focus on part number 3. Okay, so for part number 3, they are saying that the length of the string selected deviates from the mean by more than 28 cm. So this kind of question, highlight the word deviates from the mean. Okay, or sometimes you will see the word something like differ from the mean. Okay, these two have the same meaning, deviates from the mean, different from the mean by more than 28 cm. When you want to write the symbol, please make sure that you write it out correctly. We have quite a number of these kind of questions in exam, so make sure you know properly how to write the symbol correctly. Okay, so I want to find the probability that x deviates from the mean. So x deviates from the mean means x difference from the mean. Okay, when we write x difference from the mean, mean is 150 for this case, right? Mean is 150. Okay, all right. So when I say x is different from the mean, that means x minus 150. But it can be also 150 minus x. All right. Okay, so deviates from the mean have two meaning. Either is x minus 150 or 150 minus x. Therefore, when I want to combine these two, okay, become one symbol, it is modulus x minus 150. Okay? Can or not? Alright, so this is how we actually do it. So it is a bit tricky, but they will ask you very frequently for this kind of question because the sentence is a bit different. Okay, so remember that when you see the word deviates from the mean or deviates from something, differ from something, then the symbol should include the modulus sign. Okay, so I put it here first. Modulus x minus 150, okay, by more than, so more than 28, so 20. Okay, and then some students say, if let's say I actually don't know how to use the modulus sign, can I straight away write it out like this? Because I know that x minus 150 and also 150 minus x when we have the word deviates from the mean, right or not? So some of them will straight away write out x minus 150 more than 28 plus 150 minus x more than 28. Okay, so if you want to write out like this, also can. No problem. Okay, understand? So I hope that you understand this. Alright, so for me, I will always write out the modulus sign. Up to you. Actually, later when you expand it, they are still the same. Okay, so let's continue. Right, so okay, modulus greater, right? So modulus greater means that I want to find out the value by the sign, which means if I expand it, it will become x minus 150 greater than 28, then plus x minus 150 smaller than negative 28. If you follow the value or the steps I showed you just now the other way one, okay, and now you'll get this equation also. They are the same actually. So it depends on how you understand the question, right? So for me, I will use modulus. For you, you can straight away write it out separately. X minus 50 more than 28, 150 minus x more than 28. So if you convert it again, you'll see this one. Okay, then for this step, right, I don't know whether you can see or not, but I will just show you first. Okay, if let's say, just to do it normally, this is x greater than 178. This one is 150 minus 28, then you get 122. So it looks like very normal, right? Okay, so again, standardize it, become z. So how you change it become z? It will become 178 minus 150 divided by standard deviation. Then plus z smaller than 122 minus the mean divided by standard deviation. Okay, then what do I have here? I will have more than 2.8 and also z smaller than negative 2.8. Okay, so from these steps onwards, I want you to try it out on your own, how to get these two probability. The final answer should be 0.0052. Okay, so what I want to guide you is actually the answer, how to start that, how to start it correctly. Yeah, so you can complete the steps here. You should be able to get the answer 0.0052. Right, then just now I said, right, because I just do it normally like this. Okay, so the steps looks like very logic. Okay, for some students who are very clever one, they will see that, okay, 178 minus 150 is actually 28. Right? 122 minus 150 is actually negative 28. So some of the students, they might skip these two steps and straight away jump to this one, where they will straight away change it become z. Then they just take 28, because 28 is already minus the mean value, then divided by standard deviation. Then plus z smaller negative 28 divided by 10, then they straight away come to this step. Also can. It depends on how you look at it. Alright, if let's say you can see clearly, okay, you can skip the step here, become 178, 122, you straight away can skip and get the 2.8 if you wanna. Alright, so this is just a suggestion if you can see it. Alright, so please complete this example to get 0.0052. Okay? Right, then if no problem, then continue to the next example. Okay, so for this example, again, you can see the keyword normal distribution. It will show appear in the question, right? Okay, so they tell you that the mean is mu, the standard deviation is standard deviation, sigma. Okay, so you write that. But you don't know very right, so never mind, just write it out. Right, so here, if 800 observations are taken from the distribution, how many would you expect to between this one? So that means your x, they want to know how many of your x is between mu minus sigma and also mu plus sigma. Okay, so again, I want to know at first my probability of x between these two numbers. Okay, I want to change it become z, right? How can I change it become z? This is the original value mean, original value for x. To standardize it, you need to minus the mean divided by standard deviation. So the same thing happens for this. Okay, then now you don't have any value here, but you still can continue because mu minus mu is 0. Negative sigma divided by sigma, you have negative 1 here. Okay, so you can try to find the answer for the probability, which is z between negative 1 until 1. You should be able to get 0.6826. Okay, all right. Then after you get 0.6826, they said now I'm 800 observation. This is for the percentage or probability for one X. Okay, and then now you're having 800 of them. How many is between this value? So I just change the question a little bit. If let's say I'm having 800 students taking exam, and I want to know how many of them they score between this and this marks. So how can you do it? After you get a probability of the student who score for this and this mark, then you need to multiply with 800 so that you know how many students score, right? Okay, so the same concept here. To get the number of students or number of observation, you need to take the probability that you get for that particular value, multiply with 800. All right, so you should get 546.08, and after that you should get 546. If you change, it become 3 significant figures. All right. Okay, so this is how we get the number of observation. Okay, so in this example, in this part, our notes, I only provide you 2 application questions here. So if let's say you want to practice more, of course, you can try the partial question at the end of the chapter, or you can go and search for the partial question by year. There are a lot of questions actually for normal distribution, right? So you can try if let's say you need more exercises or example. Okay, so this is what we have for this video.